Hey all, welcome to another session with me, Varun, at OdinSchool. And in this session, let us understand some concepts of object-oriented programming language, or OOPS as we also call it. And we would be focusing on understanding what is class, object, and inheritance in this very session. And I hope by now you all must have had understood why is Python very important and how is Python useful for data science. Now, in these sessions, we will be focusing on the foundational level concepts of Python programming. And as we keep going ahead, we would be advancing into the very important aspects of it. Now, to give you all a small introduction about OdinSchool, we at OdinSchool are a technology upskilling platform and we would help you continuously acquire new skills. Thereby, you could stay skilled and stay ahead. And guys, you all know me. My name is Varun, and I have an experience of 7+ years, wherein I've been working on different languages like HTML, CSS, Python, R interface, RStudio, Anaconda Navigator, etc. And I've also been able to get hands-on concepts like machine learning, deep learning, and others. All this is credits to the organizations that I worked with, as I always keep saying. So now, without wasting time, let us go further and understand the agenda of this session. Well, the agenda would be to look at the class, to look at what is an object, and the concept of inheritance. We might touch base upon other concepts as well, which are important for us, but these three would be the topmost priority of this session. Now, when we talk about the concept of object oriented programming language, well, we have five very important concepts that come into picture. The first one is polymorphism or inheritance or abstraction. I don't know, you can begin with the first one anywhere. Okay, we'll start with object. After an object, the next in order is a class. Then we have something called as abstraction, followed by polymorphism, followed by inheritance, and then encapsulation. Now let us just understand each of these in at a basic level so that we are in sync with the latest terminologies that are available in and around the market. All right, let me use my pen so that it should be a bit more useful for us. Cool, we have it. Now let us just understand each of these without any confusion and probably in a phase-wise manner. So we'll begin with class, which is the first one. It is generally a collection of objects. When we talk about a class, it is collection of objects. Now, why is class very important, or what does it have? Let us assume that you have an employee class, then it should contain an attribute. For example, now if I say I have a set of employees and if it is collection of objects, okay, now this if is an employee record, what would you generally expect? Name, probably their age, probably their sex, and their designation. Now, all of these properties are to be kept within employee. Now, this happens to be a collection of objects, right? So, this is how we work, or this is how we understand the first part of it, that is class. Now, when you talk about the syntax, or how do we work on the syntactial pattern of a class? Well, it's not very difficult. You would be giving a keyword which is class. Now, this happens to be the keyword, followed by the name of the class. I might name my class as XYZ. Then I would be giving in my statements, whatever, and my class would then be created. Right, guys? So this is how we work on a class. Now, after class, the second one that we would be discussing about would be an object. Right, now what is an object? Now you can say that it is an entity that has a state and a behavior. It can be a real time or a real world object also. Okay, so when we talk about an object, it is a entity that can be seen, or now when I say seen, I don't literally mean that you can see it or feel it with your chair or with your hand, but then yeah, so when we talk about an object, it has to have things which have a state and a behavior. All right. When we also talk about object, it is not very difficult or different when we talk about the implementation part. It has almost everything. It has attributes and methods. Okay. And all functions, they have built-in attributes which return the docstring defined in function source code. These are also, very basics which are important. Now, when we define a class, it needs to create an object. Okay, so you can say within one, I'll just write these here, you have two. Okay, and why do we need object within a class? For memory allocation. So these are the two important things why we need them. Now, if you could consider a very small example about object, well, it, as we know, it falls within a class. The class happens to be the parent or the hierarchy with respect to object. So within a class, I would consider a class of XYZ. Okay. Now within XYZ, I would now be taking an object. And how would I be taking it? I can create some random definitions. Okay, some definition of init. Okay, and then I'll give my A, B, C, followed by, you can use self here. There is something called as self, or I would use self, comma A, comma B, comma C. Now I would give them self-returning commands like self dot A, self dot B equal to, and then I would be checking my output. And how would I do that? I would create another random variable like D. D is equal to, we have taken the name of the class XYZ. XYZ of, I'll give the requisite record. Okay, and when I click on print, or when I click on show output, you would be seeing that you have within cars, you would be having something, or within XYZ, or within this class, you would be having something like ABC. So in the output, you can only see A. You would not be seeing the whole class and the entire hierarchy structure. All right, guys. So class and object are within one another. So first you have class, and within class you have objects. They might sound a bit easy, or they might sound as if we know them all. Guys, trust me, they become very, very important from an interview perspective. Now, when we today, let us also work on a small hands-on model wherein we would be using concepts of object-oriented programming. And now let me take you to the coding part of it, just to show you a difference. Right. To begin with, here you have OOPS. OOPS is object-oriented programming language. It just sounds like how humans have hands, legs, etc. And name and age are objects of male. See, that's what we were talking about. They could be actual entities which you can go feel, touch, and you can drive them. It could be a car, it could be a hand, a leg. They are all actual entities. Now, objects, they have physical existence. That's what we were talking about right now. And classes are just a logical definition, which means that within classes you have objects which are physical entities. It's like within an attendance register we have all the names of the students or of the employees. Now, this attendance register, which we are talking about, if that is a class, the names inside it, or the names within it, happen to be the objects. Because even if I call A, B, C, all of them are available in the class, and I can go and actually touch them. They're all physical. They're all of physical existence. So that's how we understand this. Cool. So here in the first statement, as you can see, let us not talk about encapsulation and polymorphism right now. We'll go with the theory. We'll go in parallel with the theory so that you are able to get a hold of it. You know what exactly is happening here and how do we do it. That's how we would want to understand things, at least as long as we're in the initial phase. Right, guys? And also, just to let you all know, as a forward, if in case any of you are not able to understand anything, then you all know what to do. You all know where to hit your response or query. Please do that in the comment section below. And it's an assurance that me or my team, we would get back to you at the earliest. At the earliest. Right, guys? So when we talk about a class or an object, just as a one-line definition, you can say that class is a blueprint of an object, while an object is defined and created from a class. Class is a blueprint, while object is defined from a class. So we now know that they are hierarchical to each other. Now in line number 8, let us actually create a class. Okay, so here I'm taking a class and I'm giving it a name, that is class name. You can give this to be X, Y, Z also. Okay, guys. Now, once I create a class here, I would, in my next step, be giving it a variable with a value. Now, my class name has a value that this is a class variable, as you're able to see, within which I'm again taking a self-defined function and I'm printing I'm inside the class. Now, guys, here is the first question that I wanted to ask to all of you. Do you really think both of these statements are within the class only, or are they within the function and the class respectively? Or what is your understanding on this? Please put the video on pause for a second, answer this, and then probably you can get back to listening. And because of this, you would have a cross verification if you are able to understand things correctly or not. Trust me, guys, this exercise should help. All right, so now I am considering another variable with object 1 and I'm stating that I want my class name to get passed into object 1. And once I do this, I'm doing object 1 dot variable, which is this is a class variable. So this part of the information should now get populated within object 1 because class name has these two functions within them. And that's exactly what we're trying to check here. So when I do that, I see that this is a class variable. And if I do object one dot function, then it says it is inside the class. Right, guys? So I hope we have understood how to create a class and what is the importance of a class. And also, when we work on a class, please note that a class can have multiple definitions or a class can have multiple objects. There's no steadfast rule that your class should be restricted only to one object. Right, guys? So this is how we understand what is a class and what is an object. Now, going to the next part of it or going to the next concept which we have or which we plan to cover is a method. Okay, I don't think we have a method which is written here, but let me go ahead and explain what a method is. Now that we have understood what is a class, what is an object, the third one I would want to talk about is a method. Okay, now method is a function and this function it is associated with an object. So the hierarchical chain is class, object, method. Now we would be looking at this hierarchy in a coding platform or on a coding structure too, guys. All right, now that is something that you need not get worried about. Cool. Now, what is a method or how do we infer the use of a method? Now, whenever we talk about a method, now we already know that method exists within an object. And whenever we talk about a method, uh, it is not something which is very unique. Okay. An object can have multiple methods. For example, one class is unique. One class can have multiple objects, and multiple objects can have multiple methods. As simple as that. Okay, and it is a small logic that we would want to write, or it is the end logic that we would want to deliver, or that we would expect the system to execute within a system or within a concept. Cool. Now the next one is polymorphism. Okay, and even before that, we have other concepts that we are able to see. For example, we have inheritance, we have polymorphism, we have abstraction. So let us take a look at all of them individually. So we'll start with what we have here on the screen now that we've covered what is a class, what is an object, and what is a method. The next concept that I would want to talk about in order is inheritance. Now, what is inheritance? Well, it is a very, very important concept, guys, inheritance, or I would say the entire object-oriented structure in itself is very complex and very, very important. Now, it kind of simulates the real world concepts of inheritance here. It tells us that there are certain features or there are certain qualities that can be inherited by the child class from the parent class. To keep it more simple and more easy, you or me, we all might have had some qualities that we must have got from our parents, correct? Or from our grandparents. Now, this is exactly what we talk about inheritance. Inheritance is nothing but passing of those qualities, probably, or it is passing of these features from one variable into another. And whenever we use inheritance, we can create a class which uses all the properties and behaviors of another class. Now, let us assume I have two classes. Okay, the first one is class of cricket, and the second one is class of some other game, okay, which is very much like cricket, okay, like XYZ. Now here, if I have properties like runs, score, and wickets, and if the same properties are shared in class XYZ, then guys, we can use all these features here. And this technique is called as reusability. Right, guys? Now, reusability is a very, very important concept that we use here, or that we come across whenever we work on Python. Okay, now this new class that we derive or that we get, okay, that is XYZ that I've created below. It is called with multiple names. It is also known as derived class or child class or inherited class. All of these names are given only to that. Okay. And by using inheritance, like if someone asks you as one sentence, why do you use inheritance? The simple answer is it is used because you can create classes which have properties of another class, or you can create a behavior which has the behavior of another class. Cool, guys? The next one on charts is polymorphism, and let us talk about it now. So we've covered a class, we've covered an object, we've covered method, we've covered inheritance. Now we discover polymorphism. Uh, as you can see, this is two words. Poly is multiple, like by, uni, by, tri, poly. This is the sequence of how we go, right? So, and then you have a first, okay, the first, so if the first one is poly, which is multiple, the second one is morphism or morph. Morph. Morph is basically to change. Okay, it is to change shape or dimensions. Right? Now, by polymorphism, we understand that one assignment or one unit work can be done in multiple ways. For example, you have a class animal and all the animals speak, but they speak differently. Here, speak behavior can be understood as polymorphism because all the animals speak, but they speak differently. So the abstract animal concept does not actually speak, but specific animals have a concrete implementation of the action speak. So in cases like these, which I have just specified, we may want to use concepts like polymorphism. Right, guys? The next one is encapsulation. And encapsulation is also very important. Now, when we talk about it, we have encapsulation in the fifth place. Okay. And what is encapsulation? It is an essential aspect to OOPS. Okay. It is whenever you might want to restrict. Okay. So encapsulation is a restrictor. Okay. Whenever you might want to restrict uh, the usage of methods or objects. Okay, restrict the usage of methods or objects. That is when you might want to use encapsulation. Okay, in encapsulation, code and data are wrapped together with a single unit from being modified by an accident. Okay, and why do we do this? Because you don't want clash of elements, right? For example, there are different elements which use the same features, right? Now in cases like these, you don't want them to clash, do you? And that is when we use encapsulation. You might want to encapsulate A within B. Right? So I hope what is encapsulation is understood. And finally, we have data abstraction. This can be called abstraction of data or data abstraction. This happens to be the final thing, or the final palette on our discussion. Cool. Now, please note that 5 and 6 are often referred to colloquially, or they are often referred to as synonyms. Because if you want to work on data abstraction, then you have to work on encapsulation. It's like you have to encapsulate in order to work on your data. Abstraction is used to hide internal details and show only the functionality. For example, when we all switch on the Windows system, right? When we all switch on the Windows system, we notice that you hear a sound, a welcome sound that comes to your welcome music that is played. And this welcome music, which you see, it actually gets executed. You can hear the music, but this part does not disturb any of your workflow. It does not slow your system. So you can say that this noise or this sound that is created by Windows system, the welcome sound, is hidden, right? So that is where, or that is how we use them. Cool. So I hope you have understood what are these 5 concepts and how are they very, very important for us when we go into the real-time paradigm. Now what we do is let us go back to the hands-on part of it. The screen looks a bit too shabby, right? And let us just understand what we've discussed, like on a quick glance through. Now, these are concepts that we've already worked on earlier, but we kind of never saw them in detail. So in this session, we would try to understand the same concepts a bit in detail and then move further. So as you're able to see in my second step, I'm creating an object 2 with a class name, and I'm stating that this is an updated one. And this updated one, which we are using here, is important. So now let us see why it is important. So I'm taking an object 2 with class name and I'm passing in a variable into my object 2 which says that this is an updated one. And then when I print, I'm printing my object 1 dot variable. In my next line, I would want object 2 dot variable. And object 1 says that this is a class name. And object 2 says that this is an updated one. So that is how these both differ from each other. In the next step, we are creating another class with the name student, and in this I have two constructor methods. Cool. The first one is definition and the second one is print method. But my actual logic is within init method, while kind of output execution is what you would see in print method. Right? And by virtue of using init, you see I have self, I have name, I have branch and an year, and all of these would now get, all of this information would now get picked up from my line number 7. And how is that? It is because of the small association which is student. You can see I have a student here which is the same name as the class. So your system would be able to understand that within student you have 3 values and the 3 values are name, branch and year respectively. Which is the reason why when you check the output, you would see this variant of execution. Cool, guys. So I hope you have understood, and I hope it is also very straightforward to understand. This brings us to the next concept, wherein we would be talking about each of them in detail. Now that we have understood what a class is and we have understood what an object is, let us explore them in depth. Now, whenever we talk about a class, right, in Python, a class is an object-oriented programming language which produces almost everything. It has properties and methods, and a class is like an object constructor for creating objects. And these objects are very important, which is the reason why it is called as object-oriented programming language. Right, guys? And whenever you talk about a class declaration, we could impose or include or use the following features. That is, you could have a modifier that is a class that can be public or it can have default access, like anyone can access it. Or you can give it a class name, and the name should begin with an initial letter. These are the two mandates, these are the two requirements when you're working on a class. Right, guys? It's pretty straight. Now, if we go a bit further into the class only, there are different terminologies associated with it. The first one being superclass, the second one being interfaces, the third one being body. Correct? So now let us just understand what they are in succession. The first one, which we are talking about, a superclass, it is the name of a parent class, or it is also called as, I think, superclass or class is what we call it. Then you have a child. Okay, child is also called as an inherited class or a derived class. So yeah, superclass, a parent class, a class can only extend to one parent. Okay, guys. The second one is interfaces. A comma separated list of interfaces implemented by a class. So it means that one class can have interfaces. A class can implement more than one interface. That's exactly what I was saying. The third one in the list is body. The class body is surrounded by braces. So wherever you see you have flower brackets, assume that it has braces. Right? Then we have an object in the next phase. This is exactly what we were discussing a while back. Object is a basic unit of object-oriented programming structure or an object-oriented programming language, and it represents the real-life scenario. A typical Python program, or or any program which we talk about, it has n number of objects. Guys, there is no programming or there is no real-time structure which I think exists with only one class, one object, and one property. That is something which at least I have not seen on the real-time front. For the sake of practice, yes, we have seen how to create that just now. But if we are talking about any of these on a real-time front, then guys, there hardly exists, any scenario where you have such low number of classes or objects being created. Cool. Now, when we talk about an object, it consists of multiple things like a state and a behavior and an identity. We have already discussed that most of the times an object can have a physical existence. I hope you all still remember the attendance example we were talking about, right? So here the first one is state. And as you can see, a state is represented by attributes of an object. It also reflects to the property of an object, like when we talk about a state, right? And then the next one after state that we see here is a behavior. And behavior is represented by method of an object. Cool. It is the method of an object and it reflects the response of an object. Basically, behavior talks about the logic. If you want to understand things in a better way, in an easier way, if your logic is working or executed fine or not. The third one I have in order is identity, and it gives a unique name to an object. When we talk about identity, like every object has, like, let's assume I have object 1, object 2, object 3. All of these should be having a unique name, and this enables one object to interact with another object. So I can tell my system that object 1 is to object 2, object 1 plus object 2 is equal to object 3, something like that. Cool, guys. So this is how we work on each of them. Next one is inheritance. Right now, it is one of the most important concepts that we use in object oriented. Let me repeat this again and again. It is a mechanism by which one class allows to gain or allows to borrow features of another class. There are different types of inheritance that we see which are in existence. You have single inheritance wherein there's only one feature that's being borrowed. You have multi-level inheritance, hierarchical inheritance, multiple and hybrid inheritance as well. Firstly, there are some definitions or terminologies or some important words that we might have to understand even when we talk about inheritance, of which the first one is, as you can see, let us just put this here for a while. You have the class features that are inherited, which is known as a superclass or a parent class, which I suppose is very well understood by now. Then we have a subclass, the class that inherits features of another class. Now, this is the actual work or the actual feature of inheritance. Then the next one is it also supports reusability, which is by far the most important point if you ask me. All right. Now, inheritance also supports reusability. So, guys, inheritance in actual parlance can be used for a lot of factors, or it can be used to do a lot of things, or it can be used to achieve great complex programming syntaxes, because inheritance, as I said, is of utmost importance, at least in the field of Python programming language. And going forward, let us just understand the different types of inheritance we have. So to begin with, the first one that I have on the charts is single inheritance. Here, we would be seeing that there is a feature from A which goes into B, and B would now exhibit qualities of A. It's like you have a father or a mother or a brother, you see that their qualities are in you also, right? Now, this is a classical example of inheritance. The second one that I have here is multi-level inheritance. Multi-level inheritance is moreover a derived class, and here we would be inheriting a base class which would further more keep going down, and this is also called as a trickle down effect. Here the actual features are with A, or the actual features are with parent class A, or the base class. From here we have B, wherein B would be using or taking in certain features from A, and then it would pass it on to C. By this way, we see that almost if there are 10 elements or if there are 10 classes, class 1 can have shared anything, or class 3 could have shared anything from class 1 or class 2. And that is how multi-level inheritance works. Right, guys? So this is what we mean here. Then the next one is hierarchical inheritance. And when we talk about it here, one class serves as a superclass to more than one subclass. Guys, there's a very small difference between multi-level and hierarchical. Here, you might see that, okay, let us assume for a second that this is a senior manager and everyone here are managers. So here I see that it's not A to B to C, rather it is A to B and C. Because both of them are managers, A would be telling them what and how to do. Right, guys? So this is how we work on hierarchical inheritance. Uh, within which I have some case studies that we might want to take a look at, and we should look at it right now. So the first one that I have is inheritance, which we were discussing about, right? And here, what do we have? I have a class which is with the name fruit, right? I've just considered some random class, and here I'm creating a definition, or I'm creating an object within init, and I'm printing I'm a parent class. Obviously, init has to be the parent class. Then I'm considering another class again with the name citrus, and within which I have fruit as well. Fruit is the one which I've created here, guys. And when I do an init here, or within my citrus of fruit, and I would want to check the superclass of it. And when I print I am citrus fruit and I am from fruits, and I click on citrus, which is my second class, you see within citrus I have A and I have B too. This is a very simple case, or the most straightforward explanation of a single inheritance case study. And here in single inheritance, as you can see, there is one class which is acquiring the property of another class. Simple. Then we have multiple, and here in multiple, you have two classes, two parent classes to be honest, wherein I am considering class of A and class of B. And I would want to check if class of C is acquiring properties from A and B or not. And in order to do that, I would be creating a third class here, which is class of C, within which I would pass A and B. And by virtue of doing this step, I would now check if both B and C have been passed in, sorry, if both A and B have been passed into C or not. So this is how we are doing it here. So have two classes onto the top. Earlier we have seen this variant A, B, C. Then we saw this variant that is A, B, C. Now we are looking at a variant which is exactly vice versa of this. I have BC on the top and I would want to check if features of BC are going into A or not. This, if is a top-down approach, this is a bottom-up approach. But yes, I hope what is inheritance is very clearly understood now. Or rather, being more specific, what is a simple single variant of an inheritance must have been understood. Good. Now let us go into the multi-level, which we are talking about right now. So I have passed, okay, let me just remove all this. So here I have A and B, and I would want to check if these features are going on into C. Within A, I have taken some elements. Within B, I have taken some more elements. And how would I check if it is available within C or not? That is the reason I'm saying, or I'm typing is subclass C comma A. I'm asking my system, is A a subclass of C or is it not? The same is for C comma B as well, wherein I'm asking B if it is a subset of C or not. And when I'm doing this, it's giving me an answer of true for both of them, which means that there is A and B which is passing into C. And this can be very clearly understood. Sure. So now that we have understood this, let's go back to the next. Yeah. Now that we're done with multi-level, the next one on the foray that I have here is a hybrid inheritance. Now that we've already seen a few, let us go back to the place where we started from. So this is an example of hierarchical inheritance. Well, the next one is multiple. The only difference between multiple inheritance and hierarchical inheritance is, or there are only a couple of differences when we talk about hierarchical. Hierarchical can have top to bottom, bottom to top, any kind of an approach. But when we're talking about multiple inheritance, here we are not talking about the level. We are not talking about if someone is a superclass or if someone is a parent class or not. So that is how we work on multi. And the last one that I have on charts is a hybrid inheritance. And this is a mix of the above types of inheritance, wherein we have A, which is taking features from B, B, which is taking features from C. Then again, C might have features which are going back into D. Hybrid is a mixture, it's an all mix of the above two types of inheritance, that is multi-level and multiple, right? And now I was just about to give you a demonstration of hybrid inheritance here in the step. And as you can see, I'm creating a class with the name A, then a class with the name B, then with D, and then with E as well. So how many classes do you think we have here? We have 5 classes. And within A, okay, let us just probably take the help of a pen as well. So these are the 5 classes that I have here, of which A is equal to 1. Then I have my B, which has B of A. Now because B, let us assume that B is 0. And if I have A as 1, guys, let us assume that this B has no value and A has 1. Okay, now this A's value is taken into B when I use pass. Likewise, B's is taken into C, and it kind of becomes a copy of the older classes, right? But then what I'm doing is I'm considering A is equal to 1, and then I'm passing my A into B. Then I'm passing my B into C, after which I'm passing my C into D. And I'm trying to check if E has the properties of A, B, C, D or not. Correct? So guys, this is how we work on multi-level inheritance. But if it is hybrid, then what I would be doing, I would be using class and I would be considering another element which is F or G, or I don't know. We could create another class and then we could check if all these elements, for example, C, comma D, and I hit a colon, and when I print, I would want to see that I have an answer of 1. Understood? And I hope it is. So this is the next part of it. So here A is equal to 1, which is getting passed into B in my second step, which is getting passed into C in my third step, which is getting passed into D in my fourth, and then you have E. And E is to check if all this process has happened correctly or not. Sure. So this is the concept, or this is how we work on different variants of object-oriented programming language or of object-oriented programming interface. Going into the next concept. Okay, let me just get you back to the screen. Oops. Yeah. So this is hybrid inheritance, which we were talking about. Now what we'll do is, guys, yeah, let us just go back into the concept of object oriented and let us understand these just as a forward. So inheritance is when you would want to acquire features of one property into another. Single inheritance is wherein one class gets inherited from another class. Multiple is where you have multiple classes which are getting inherited from one class. Then you have hierarchical. Hierarchical is when is also the same, but here the trickle is a bit different. It could come from low to high or high to low or however you want it. And then we have hybrid, which is a combination of any two kinds of interfaces or any two kinds of methods that we are using. So this is a brief understanding of each of them. Right, so here I have come up with something which is a bit more complex. This is something I've just created probably an hour back for us to have a hands-on explanation on this. And here I would now want to talk about how do we create a class and an object in Python. So when I talk of a class, I'm creating a class called parrot. As you can see, okay, let me just use the marker so that we understand where is what. So here I'm creating a class which is Python, within which I'm taking a class attribute, that is a bird. And inside this I'm using an init definition with self, name and age. Now these are, so earlier was class attribute and the one below are instance features. Right. So what I'm doing is I'm creating name and age. So my two variables are now up and they are kind of waiting or looking for data. Correct. And what is it? We have the name and the age. So here you can see I'm again creating two classes. The first one with the name blue and the second one with the name woo. Well, the names are pretty interesting, so you wouldn't want to miss on them. Yeah, so the first one is blue and the second one is woo. And both of them are parrots with name and age in the brackets. And I'm also pretty confident that by now we all know that whenever you use names or textual information with alphabets in it, we would be having output which is, or we would be having the text in red color. And if it is an integer or if it is a keyword, then you would be having it in green color. Cool. So till here, I've basically created a class and instances. That's it. We have not done anything else till now. And from here to here comes the main step. This is the one which is responsible for the output. This is the one which, kind of tells us. Let me just scroll this a bit below. Okay, I guess I'll have to delete things on the screen and delete it. Okay, so now when I see I would want to access a class attribute, I'm saying I want to print blue is a, but what is blue? Now, in order to get this printed, I'm using my format. That is format blue, which is the name of the element, followed by class, followed by species. And what is the species that we're using? Bird. Right, guys? So when I say print, who is also a bird? Simple. That's the text that we would be having in the output. Species. Okay, so first, second, and then I would want to access. Now here, guys, once we're done on the top step, the second step says that it is okay. So this is the name that's coming in from the data. Whenever you find curly braces or round brackets, please assume or please be confident that it might be data or text that has to come in. And here we're not having these brackets because of some data or something. As you can see, this text is enclosed within quotes or quotation marks, which is the reason why I'm having it in red. And after quotes, I have two curly brackets, as you can see, wherein each of them, like each curly bracket here, is the place where the age would be going into. So let us just compare these last two values. So first bracket is being taken by the age, by the name, that is blue and woo. The second bracket is being taken over by the age, which is 10 and 15 respectively. And guys, I hope this is understood. I hope it's very straight and very simple to know about. I have tried not to add any kinds of concepts or any kinds of coding which is very heavy, at least for the initial few days. And also, when you talk about object oriented, guys, object oriented exists in almost all languages. You have it in Java, you have it in Python, you have it in, it's like you name it and they have it. So please be very, very careful when you're referring to any materials on the internet or any materials on the websites. Be 100% sure that what you're learning is towards the same. Cool. Going forward, now how do we create methods in Python? Is the second part of discussion that we would be talking about right now. In order to create a class, we have seen how to do it already. You can just use a class of parrot, and that's exactly what we've done here too. Class, which is in green and bold, of fruit, which is in normal, and if you look at the color, this is blue. So you have green for keywords and you have blue otherwise. Cool. So now that I have used my class and directly given my definition, that's exactly what we would be doing here too. We have used a class with the name parrot, and inside this we are giving definitions. Firstly, you have init process wherein your name and age are being taken into consideration. Then you have your instance method wherein you can consider so we'll see what instance method is when we check the output. And then finally you have your other statement which returns the age or something like that. And we're not sure what all that is right now, but we would know what it is in like next 2 minutes. All right. So now that we have understood this, we could go forward into understanding the methods. So here I'm creating a class of parrot. I'm considering two init methods. Two init elements within one method. I'm considering another method for instance, and then I'm also considering another method for the final output. So here in format, when it says self name here, from if it says self dot name comma song, then it means that he sings for 20 years, something like that, as per this example is considered. So now what I'm doing is I'm taking the instantiation of an object which is blue, and within blue I'm passing parrot, and again I'm passing parrot, which is a functionality. I've created parrot here. It's a functionality, and after parrot, what I'm doing is in my next step, right in my next step, I am giving this object a name and an age, because of which it would probably tell us that blue, okay, blue, which is the name, blue is now dancing, and that's what you see here. The same is also for the step above, that is blue sings happy. And you might want to do this, this is where you go. Wherein, okay, so here you can see I have blue 10 and I'm printing. And when I print my output, I'm calling our instance method. If you can see blue dot sing and happy, that is it. I'm using blue dot dance. Now dance can be understood. Why? Because dance is a self-referencing index. So is sing. And where is the data going from? The data is going from here only. So my system now knows blue sings happy. And happy is also an instance that we have created. And likewise, blue is now dancing. And that's what we see in our output. Blue is now dancing. So to be honest, object-oriented programming structure or object-oriented programming language happens to be one of the most easiest that you could come across. It is as long as you're working on the Python front. Okay, cool. The next one that I have here for us is inheritance. And in inheritance, I have a couple of classes that I have considered, wherein the first one is class of birds. Here I have created two classes, and a whole lot of features or methods or objects as we refer them to, because every object has some methods in it, right? And that is the only logic I used when I said it. So now I'm creating a class of bird with a definition of init, and I'm printing that bird is ready. Creating another definition, again printing bird. Another definition within which I'm printing swim faster. After which I am taking child classes and I'm giving a definition of init, of self, after which I'm calling the super function, which is init, and then I'm printing it as penguin is ready. And even on the steps below, I'm taking different elements like print of penguin, print of run faster, print of run, print of who is this, things like these. As you can see, they would come into effect below. You see, penguin, who is this, swim, run, they all have been instantiated. So I'm saying my bird is ready, penguin is ready, then comes penguin, then comes swim faster, and finally run faster. So run faster and penguin are already existing on this front. Except for the sake of discussion here, you wouldn't actually have to show things which are available, visible, up and running. They are not required, or they're not even considered to be shown, right? Like now, I was talking about a real-time project, or I was talking about about when you are on floor. I'm not talking about the practice part of it. Guys, please pardon me if I have not communicated that part properly, because this part may confuse a lot of aspirants. Like, what do I show to whom do I show to, and all. So whenever you're on real-time front, or whenever you're working for an organization, there is no client or no manager who would be interested in seeing how you did it. It's all about what did you do and how fast can it happen. And in this pursuit, it becomes very, very important for us to stay updated with the latest technical terminology that's happening in and around the market, or that's happening in and around all of us, right? So this is where we have to work, or we have to learn concepts of object oriented programming structure. Also, you might want to call, or you might want to use one object somewhere else or one class somewhere else. And if that becomes a requirement, then how do you propose to do it if there is no class, or if there is no object within it, or if there is no method within it? That is when all the problem, or that is when the inconsistencies between what you thought and what you have begin. Right, guys. So as long as we are working on object-oriented programming, it would be very easy for you even to check if the logics are being properly executed, and if the hierarchy is working or not, and if it is working, then how can we make it better? So that's how things like these can be unfolded and understood. Right? So now that we've understood this example, let me also show you through the last one. Right. So here I am using a computer, which is my class, and I'm creating a couple of definitions within it. The first one being init, the second one being cell, and the third one being set max price. These are the three features, or these are the three classes. Okay, I mean, we have a class which is computer, so these are the three objects which I've created, right? So things like these can be understood here. So as I now go forward, I see that I have created a definition or an object within it, then another with cell, another with set max price. Created a variable with the name C and passed it into computer. Right, guys? Created a variable with the name C and passed it into a computer. Now I would want to add cell to this, that is C dot cell. And what would happen because of this? You can see C is my computer. So it would take in the computer and it would give me a selling price. You see, maximum price is 900. Selling price is being picked from here. And here you have format self dot max price. And what is self dot max price? It is 900. So we've seen that here as well. The second step is I would want to change the price. And how to change the price? That is C dot max price is equal to 1000. And I can use C dot sell again. Finally, I'm using set max price, which is a setter function. And whenever you want to use setter function, guys, there's no huge out of the box step that you do. You just use a set, which is a word set max price. And I want max price to be set on 1000. This is the reason why in my third output, guys, in my third output, you see that the selling price is 1000 rupees. Right, guys, so I hope this very simple concept of what is encapsulation. Let's just go back to the slide. So yeah, simple concept of what is a class, what is an object, what is a method, what is inheritance. I hope all of these have been understood by all of us. And if there's any query, guys, please let me know about it in the comment section below. Let me just quickly take you through a glance about what all we did before we call it a day. We started with object-oriented programming, then we moved on to understanding what is a class, right? After which we saw what are the different concepts that are available within an object-oriented programming structure. After which we have deep dived into understanding what is a class and what is an object. After which we moved on into understanding the concept of inheritance one by one. And in this while, we have also been working parallelly on understanding, when I say parallel here, you need to know that there are also other concepts which are still left over in inheritance. And in the next session, we would be working on the other concepts. And in the meanwhile, I would want you people to work parallelly on these concepts too, like all what we have covered. That is when it makes the entire picture complete. So then we started working on each of these variants of inheritance in detail. We've understood what they are and what they do and how they do. After which we moved on into the hands-on part of inheritance as well. So we have covered class, object, method, and inheritance. Right, guys, so these are the four concepts about object-oriented programming that I wanted to talk to all of you as far as this session is concerned. In the session coming next, we would be looking at some other concepts of object-oriented programming language, wherein you would be understanding an end-to-end of how to use it, when, where, and why to use it. So that is how it gets useful. So guys, I hope you have understood, and I also would like to appreciate each and every one for your prolonged patience and for being here with me. Thanks a lot for being there. In the upcoming session, we've still got a lot to watch and a lot to do as well. So guys, do not go away anywhere. Please hit the like button if you felt that this video has been of any use, and also do not forget to hit the subscribe button, because when you do it, you would be having access to a plethora of videos to choose from. Right, guys? So thank you once again. Have a great day. This is me, Varun Rao, signing off.